Okay, in this video, I'm going to explain moments on levers or moments on beams. You must be able to define a moment of a force. A moment of a force is defined as the energy conveyed to a point of rotation by a force, and moment is given by force multiplied by distance, where this F must be in Newton and the distance in meters. And the unit of a moment will be simple B, a Newton meter, N dot M. So when distance is not given in meters, you convert it to meters. And the force must be in Newton. Maybe if it's given in kilograms, you multiply by 9.8 to change it to Newton. Now, a moment, this turning effect, moment is also defined as the turning effect of a force about a point. A force can have a clockwise effect or an anti-clockwise effect about a point. If you have a look at this lever. A lever is a rigid bar that is resting on a pivot. So this pivot is called a fulcrum or a turning point, or is the support. There is F1, force 1 acting at the right hand of that leaf of support, and force 2 acting at the left-hand side of the support. So moments can be clockwise or anti-clockwise about a point. So if you follow the arrow of this force 1 and you push it or you turn it towards the support, this produces a clockwise effect about this point. And if you focus on force 2 and you follow its arrowhead and you turn it towards the support, this one has anti-clockwise effect about the same point. Now, this takes us to a law of moments. This law applies when we have more than one force. We can use this law acting on an object. It states that when a system of forces is in equilibrium, sum of clockwise moments about a point is equal to the sum of the anti-clockwise moment about the same point. So the moment of this force about this point will be equal to the moment of this force about the same point if this is in equilibrium. Moments will be the same. And this is the symbolical expression or representation of this law of moment. A sigma stands for sum, and a CWM is the clockwise moment, equal to sigma ACWM is the anti-clockwise moment. Now, we do calculate moment on levers or moments on beam. A beam is a horizontal or inclined structure that is supported at more than one point. Let's have a look at the next slide. The information regarding the moments on beam. If a question says this is a light beam, it means you ignore the self-weight of the beam. You ignore the weight of the beam. If the mass of the beam is given, you always convert it to weight because this law of moment, a moment is given by a force and a distance, not the mass and the distance. So you always convert it to weight so that you can get the Newton. After converting it to newtons, you place or you position this weight at the center of the beam length. If your beam is 10 meters, we place it at the center of 10 meters, which will be 5 meters from either side. Now, learning outcome. We will be calculating the reactions on the support or the unknown force. You can be given one of the reaction and the other forces, the point load. And the question will be calculated the unknown force. And you are expected or required to test the answer. Newton's third law. Number 3, you must be able to calculate the distance on which a certain force must be placed. So the things that you calculate under beams will be the supports or reactions. You're testing the answer and you calculate the unknown distance. To calculate this unknown distance, if the distance is from the right, you take the moment about the right end, because it will be closer to the right end, the unknown distance. If the distance is from the left, you take moments about the left end, unless stated otherwise. Now, a moment is clockwise or anti-clockwise about a point. Let's have a look at this example. 2.2, taken from a question paper of April 2019. Given a light horizontal beam rests on two supports, K and L, as shown in the diagram below. Ignore the weight of the beam. So this is a light beam. You're not gonna take its weight into consideration. Calculate the reaction of the support by taking moments in kilonewtons about each support, namely K and L. So we're gonna take moments about each support. Now, first thing first, this question says take moment in kilonewtons, but there is 500 that is in newtons there, and there is 0.5 that is in tons. 0.5 that is in tons. So first thing, convert these forces that are not given in kilonewtons to tons. Here is the relationship between tons and kilograms. A relationship between tons and kilogram is that 1 ton is equal to 1,000 kg. There is no relationship between a ton and a newton. So you move from ton, you take it to kilograms. So this 0.5 tons in kilograms, if a single ton is 1,000, 2 tons is 2,000. So the relationship is that from tons to kilogram, you multiply by 1,000. So 0.5 multiplied by 1,000 kg will be equal to 500 kilograms. So this 500 is only in kilograms, but moment is a force and a distance. It needs to be converted to newtons, to a weight. When converting it to weight, you multiply it by 9.8 because W is equal to mg. W is equal to mg. So m is 500 multiplied by 9.8, and you use your calculator to get the answer of 500 multiplied by 9.8, which is 4900 newtons. This would be 4900 newtons. Now this question, this one changes to 4900 newtons. It's no longer 0.5 tons. But the question is specific that take these moments in kilonewtons. It means that you need to change this to kilo, change this to kilo. A kilo is equivalent to 1,000. 1 kg is 1,000. So if you want to convert this to kilonewtons, you divide it by 1,000. So this answer will be 0.5 kilonewtons. And this one, you divide it by 1,000, will be 4.9 kilonewtons. So you take moments using the forces that are in kilonewton. The formula is that symbolical expression of law of moment. The one that states that sum of the clockwise moments is equal to the sum of the anti-clockwise moments. You can also put it this way, sum of the clockwise moments equal to sum of the anti-clockwise moment. Because we have more than one force, and this is in equilibrium, we apply the law of moment. Now, when calculating the moments, we have two supports that are unknown. They are both unknown. Both N and K are the unknowns of this question. K is unknown, L is unknown. These concentrated loads, they are called concentrated loads or the point loads. They are always acting downwards. And these are the supports. Now, when these two are not given, you need to use the law of moment and fix one of the supports. By fixing one of the supports, the other supports and other forces will be free to rotate the structure. The total length of this beam. So in order to get this thing right, you need to sketch it according to scale. I'll sketch this beam. From the left hand, there is, okay, this is the beam, 3 meters from the left end. And there's a force here that is acting down. 1, 2, 3, 4, 5. There is 5 meters. After 5 meters, there is a force of 500 acting downward. And another 5 meters. 1, 2, 3, 4, 5. After 5 meters, there is that force acting downward. And 1, 2, 3. There is a support here. So a beam is like this. The first support on the left-hand side, the distance is 3 meters, and this is 4 kilonewton. This downwards force or the concentrated load. And there is this distance of 5 meters. There is this downward load here of 500. When converted to kilonewton is 0.5 kilonewton. And there is a support here, which is L, and the distance from the right end of the beam is 3 meters. This distance here is given as 5 meters. This is how it is. Now, in order, this is K. I have sketched the beam. Here is the sketch of the beam. I use the measurement. I use the ruler to measure 3 meters from the left. And this load, 5 meters distance, this load, 5 meters and 3 meters, and place the support accordingly. Now, in order to get the value of K, you need to fix L. So to get K, you take moments about L. If this one is fixed, this one is free to rotate the structure. You take moments about the other support. You cannot fix L and you still get L. When L is fixed, K is free, you're gonna get K. Now, sum of the clockwise moments about what we have fixed, which is L, will be equal to the sum of the anti-clockwise moments about the same point. So when taking moments about L, you check what rotates this structure clockwise, because we're going to put everything that is clockwise this side. This is the structure. This is where L is. If you look at K, the arrowhead is upward and you push it towards the fixed point or the fulcrum. This K is going to rotate this structure in a clockwise direction. So K is clockwise, but it must be a moment. A moment is a force and a distance. Now, a distance will be the distance between K and L. And the distance between K and L will be 10. Let's count it. This is 3, this is 5, and this is 3. So if this total is 5, the remaining distance here is 2 meters. So it's K times 10. Moment is the energy conveyed by a force to a point of rotation. So L is the point of rotation, is the turning point. So K is conveying an energy through a distance of 10 meters to L. It's clockwise. Now let's look at other forces that are clockwise. I did not include that one. I said it's 4,9 kilonewton when converted to kilonewton. So it is K multiplied by 10, and it is in the same direction. So it's sum of the moment. I'm gonna add because it's same direction. It will be 4.9. 4.9 is conveying energy to this point through a distance of 3 meters. So it's multiplied by 3. There is no other force that is clockwise. A force cannot be clockwise and anti-clockwise about the same point. So if there is no other clockwise, put an equal sign, which is this one. Now I'm going to write sum of what is anti-clockwise about the same point, that is the law. Sum of the clockwise about the point is equal to the sum of the anti-clockwise about the same point. Now look at this 0,5. 0,5 is downwards. So if we turn or push its arrow towards this point, 0,5 is producing an anti-clockwise effect. Is conveying an energy to the same point for a distance of 2 meters. So it will be 0,5 multiplied by 2. This is the moment, force and distance. This will be plus. Look at 4. 4 is also downwards. So if we push or we turn 4 towards, you don't change the arrowhead, you follow the arrowhead and just push it towards the fixed point. This is how you turn it to that point. So 4 is conveying the energy to the same point through a distance of this 5 plus 2. So it will be 4 times 7. Now, if this point is fixed, 1, 2, 3, 4 are free to rotate the structure. So if 4 forces are free, even the set of moment will be 4. Let me count the set of moment. 1, 2, 3, 4. So all the forces are included. Next step is to use your calculator and get the answer. 4 times 5 times 0,2. This one will be 1. 0,5 times 2. This is 1 plus 28. And this is 10K plus 4.9 times 3. 4.9 multiplied by 3. This will be 14,7. This is 10K equal to 29 minus 14,7. 29. 28 plus 1 is 29. And then you subtract 14,7 from 29. And the answer here will be 14,3 equal to 10K. Divide both sides by 10. Divide both sides by 10. And this will be 1,43 kilonewtons. This is the answer. Then I'm going to take a moment about the second support. To get K, I fixed the L. Now the story will change. To get L, you take moments about K. L is no longer fixed, it is free, but K is fixed. You first fix the other support and you fix the second one. The formula is that sum of the clockwise moments must be equal to the sum of the anti-clockwise moment. It's K that is fixed. Let me use a different color. K is fixed. When K is fixed, 4, you look at the arrowhead of this 4 and you push it towards your fixed point or the fulcrum. 4 now is now conveying the energy to K through a distance of 3 meters. So a distance you use is always a distance between the force and the turning point. So it will be 4 multiplied by 3. Plus, if you look at 0,5, 0,5 was conveying anti-clockwise about L, just like 4. But now this is the turning point, the reference point. This 0,5, you turn it to the fixed point. It is now conveying energy to K through a distance of 5 plus 3. Distance is always between that force you are referring to and the fulcrum. So it is conveying 0,5 multiplied by 8. Let's look at 4,9. 4,9, we turn it towards the fixed point. 4,9 is also clockwise about K. Is conveying a distance and energy to K through a distance of 5 plus 5 plus 3. So it will be 4,9 times 13. 1, 2, 3. They are clockwise about K. Now let's look for the last one. Equal to, there is no other force that is anti-clockwise about K. Let's look at L. L is upward. So we're going to follow its arrowhead and push it towards K. So L is conveying a distance in an energy to K through a distance of this space from here to here is 2. So it's 2 plus 5 plus 3. So it's through a distance of 10 meters. It will be L times 10. If K was 10 meters away from K, even L will be 10 meters away from K. When this one is fixed, 1, 2, 3, 4 are free to rotate the structure. Even the set of moments will be 1, 2, 3, 4. Next step, use the calculator and make L the subject. So this is 12 plus 0,5 times 8 will be 4 plus 4,9 times 13. 4,9 multiplied by 13. The answer will be 63,7 equal to 10L. Then we add this side, plus 4 plus 12. The answer is 79,7 equal to 10L. Divide by 10, divide by 10. So the L will be equal to 7,97. kilonewtons. Now the question, let me go back to the question. It's a second question. Test. Let me look on the original question paper. Check your answer, 2.2. When checking the answer, remember the law of moments, we say this is in equilibrium. If it is in equilibrium, clockwise are equal to the anti-clockwise. So when testing, test is a test or the check. When checking the answer, the sum of the upwards forces must be equal to the sum of the vertical downwards forces. That is the condition, Newton's third law. For every action, there must be equal and opposite reaction so that this is balanced. That is the condition. Now we look at this beam. What is upward here is K and L. The arrowhead are facing up. So K plus L is the sum, are equal to what is downward is 4, 0,5 and 4,9. So it will be 4 plus 0,5 plus 4,9. K and L, 1,43, the value of K, and the value of A is 7,97, equal to the sum of this side is 9,4. 9,4 kilonewton. When we add this side, 1,43 plus 7,97. The answer is 9,4. So 9,4 kilonewton is equal to 9,4 kilonewton. It means the calculations are correct because the downwards forces are equal to the upwards forces. It satisfies all the conditions of equilibrium. Thank you.